want to remind everybody to take a look at the Women in Drones webpage because we have the Women to Watch going on right now. Definitely want to voice your opinion in there because there, like we said, so many amazing people in the industry. I want to introduce Bill Fredericks. He is going to be doing our presentation today. Bill Fredericks is with Advanced Aircraft Company, and he's going to demonstrate the, and I hope I do this right, the HAMR UAS, and it is a hybrid advanced multi-rotor. That is the key. That is so awesome. And we actually get a demonstration for this. He's the founder of the Advanced Aircraft Company, and he has a very, very impressive background in aeronautical engineering. He began working at NASA Langley Research Center as a co-op student, and his most notable project at NASA was this is fun, Greased Lightning UAS project, where he performed the conceptual design of the aircraft and led the project through the flight testing phase. How awesome is that? And he's here with us today to do a live demonstration of this. So hello, Bill. How are you doing? And thank you so much for joining us.
Hello, everyone.
Welcome.
Yes,
Yeah.
hello. Very nice to meet you all. It's beautiful weather day here in Virginia. And today, let me flip the camera around so you can, where's the flip around button? Here we go. So let me introduce, we got two of our team members here. Moshe's an aeronautical engineer and Paulo's an electrical engineer. Today we're going to start demonstrating the aircraft. So here it is sitting in the case. So the aircraft itself packs up into a case this big. I have a Ford C-Max, which is a small hatchback car, fits inside my car. We also have gasoline and the camera. This is a full-size DSLR Canon camera. And I'll continue talking as Moshe and Paulo start assembling it. So go ahead, gentlemen, please start putting it together. So part of this demo is to show how rapidly this is set up. And we'll go not at full speed today, but we have actually demonstrated 4 minutes from the time you put the car in park to the time we've had it lift off. And right now they are just pulled the fuselage out. So one of the really unique things about this aircraft, go ahead, I'll work around you. One of the really unique things about this aircraft is the engine. And on the back end, this is an engine turning a generator. Actually, if I point like this, so this is a high frequency AC generator. This is the engine. It's liquid cooled like a modern automobile. It also has full computer controls in it. So it is a 2-stroke gasoline engine that's all computer controlled and fuel injected. So when you think about a 2-stroke engine, you normally think about a weed whacker or a chainsaw, something very cantankerous. And most of the reasons why 2-stroke engines are cantankerous is because of the carburetor. So the carburetor, especially with our gasoline nowadays that has ethanol in it, tends to gunk up. And you often have to clean out and rebuild carburetors periodically for the engine to work well. There's no carburetor on this engine. It's computer controlled, fuel injected. And the layout of the vehicle itself, well, let me talk, when we at Advanced Aircraft Company say hybrid, oftentimes in the drone space, when people talk about a hybrid drone, they're referring to a quadcopter and a fixed wing having a baby, like a hybrid configuration where it's part airplane and part quadcopter. This vehicle, when we say hybrid, we're referring to hybrid propulsion, like a hybrid car. So gas engine turning an electrical generator, producing electricity, is pushing electrical power onto the 48-volt DC bus of the aircraft. And then there are smaller lithium polymer battery packs on that DC bus. And then power is drawn off that electrical bus to spin the 6 motors and 6 propellers. You can see right now we're loading gasoline into the aircraft. And when you think about the logistical footprint of a typical battery-powered multi-rotor operation. Pardon me. Um, Everyone obviously thinks about the aircraft, but oftentimes what people don't talk about is the logistical footprint to support a battery-powered multi-rotor operation that has to survey a large area. So one of these big enterprise level drones from DJI, it simultaneously requires 6 batteries to fly it. And then you have to bring at least 4 sets of batteries with you. I've heard from some prospective customers, they oftentimes bring up to 10 sets of batteries with them. And so you got to bring a generator, like something you buy from Home Depot, for example, to run battery chargers. And you need at least 3 battery chargers, because usually it takes 3 times longer to recharge a battery than to use a battery in flight. And all of this, and by the way, you normally need about 6 gallons of gasoline to run that generator all day long. And to fly this aircraft all day, this is a 2-gallon jerry can in our fueling station. And so we actually burn about 1/3 of the gasoline as the battery-powered multi-rotor we replace. So there's actually an environmental benefit to the technology as well. What other topics? Going through the aircraft here. So now we've got the camera on the nose, and the aircraft is fully assembled now. We're still loading gasoline at this point. Okay, just finished loading fuel. 3 pounds of fuel are installed in the aircraft. And a rule of thumb with this aircraft, for every hour of flight time, you need about 2 pounds of fuel. So we just loaded about an hour and a half worth of fuel into the aircraft. So when you guys are ready, go ahead and take it out to the takeoff site and start it up. Some characteristics of the vehicle. So maximum takeoff weight is 40 pounds. Here's Moshe picking it up, walking it out. So the maximum allowable takeoff weight is 40 pounds. The empty weight of the aircraft is about 32 pounds. So there's 8 pounds of useful load to work with. So useful load is the sum of gasoline plus payload. So as long as your weight in gasoline plus your weight of payload is less than 8 pounds, you can safely fly it. So we can carry a full frame DSLR camera, which we're carrying today for part of this flight demo. And yeah, where's it gonna go next? I just had a brain dump. Why don't I pause here for a minute while they're turning on the electronics and take a couple questions.
Sounds good. I actually have a couple just right from, oh, yes. Sharon just posted into the chat also as a reminder that you are hiring at this time. And so you're looking for a mechanical engineer with drone experience. So we just popped that into there. But I have a quick question about just the basic right from the beginning. That case, how big is the case? How big is the drone once it's expanded to its full length? I know we kind of talked about the weight of it, but as far as the case itself and the drone itself, what is the size of it?
Yeah, the case itself is about 55 inches. So to give a sense of, I don't know, I can't really get myself in the video easily. The exact dimensions are up on our website, but it's about 55 inches long. I think it's like 20 something inches, no, like it's like 30 inches wide, and I believe 18 inches tall. So it is a fun fact. It is the largest dimensions possible that you can just walk into a UPS store and say, hey, ship it to this location. We have found that UPS really beats stuff up, and they oftentimes don't handle things gingerly. But actually, Moshe's about ready to do. Why don't you do the short hop first, and then we'll talk through planning the mission. So here we go. We're set up at the ground station. Wonder if I can.
Found that we are charging. All right.
And notice as he started the aircraft, he did not need to touch it. The generator itself acts as the starter to crank over the engine. So all computer controlled, fuel injected. And he's doing a controls check right now to verify it's responding properly. It's testing pitch, roll right, and rolling left. Okay, controls check out. So just lift it up a foot or two. All right, and it's up in the air. Okay, so he's gonna set it back down now, and we'll plan out a mapping mission.
And we do have a few questions that have popped up into our chat before we segue to the mapping mission.
Sure.
One of them would be, how does it meet emissions standards?
There we go. Let me turn this around. Actually, fun fact, there are 0 standards for emissions for drones. So having said that, though, we are an environmentally conscious company. And since it's computer controlled and fuel injected, it is actually quite emissions friendly. We're not putting in any more fuel than we need to because we want to maximize flight time. So we want the fuel efficiency to be as best as possible. So we're using all of the fuel that gets injected into the engine, the result of which there's a very clean exhaust stream because there's not any extra fuel dumping in and dumping out of the exhaust. The exception is on startup. It automatically gives more fuel on startup to help it choke over. But once it's up and running, it leans the mixture right out. So the fuel, so the exhaust is relatively clean. Relative to any other small gas engine, it's dramatically more environmentally friendly.
Awesome. Couple more questions if we have a quick second here. What is the country of origin? Does it meet US made specs for non-China operations?
Yes, absolutely. So the aircraft itself is made by our team right here in Virginia. And I forget the exact numbers in the federal government standards of what's considered made in the USA. It's a percentage of your bill of materials and a percentage of the labor hours. I don't recall what the exact numbers were, but from a percentage of our bill of materials, we are well above the threshold, what's considered made in America. And as a percentage of the labor hours, 100% of the labor hours is done right here by our team in Virginia. So we are absolutely made in the USA.
Awesome. And then to continue on with the same, Jim Bonnerdale had a question. What does the fuel have as far as the oil mix ratio?
It's a 40-to-1 ratio. So on the red jerry can, you put in the appropriate number of ounces into the red jerry can. Then you go to the same gas station for your car. Instead of doing regular, you do have to use premium, so like 92 or 93 octane. And you just put in the appropriate amount of oil, then grab that pump from the fuel station, put 2 gallons on top of it, and it mixes it. So it's a 40-to-1 oil mix, and you have to use premium gasoline. A side note, the reason we have to use premium gasoline, if you look at the power we're producing relative to the displacement of the engine, we're getting over 3 horsepower at the crankshaft, and it's only a 35 cc engine. And that power to displacement ratio is actually on par with Formula One racing, which is a pretty impressive performance. So we're running that engine really hard to get a phenomenal power to weight ratio. Another way to think about it, so this engine, we are generating 2,000 watts of electricity to fly the aircraft. And if you go to Home Depot and go buy the typical 1,800 watt generator, that's like a 50-pound deadlift to pick up an 1,800 watt generator. Here on this aircraft, we're getting 2,000 watts, and that whole system is about 6 pounds. So it's just a phenomenal level of performance.
Awesome.
We can transition to doing the mission planning. Here, let me turn around the camera.
Okay.
And all right, so Moshe, sort of think out loud, and I'll zoom in on the screen and show how to plan out a photogrammetry mapping. Actually, let me come to this side for the sun angle. There we go, that's better. How can everybody see the screen nicely?
Yeah, it looks like there's reflection on it, but if you study.
I see an arm.
Yeah, we see an arm, but if you look through the arm, you could actually see the plotted area.
Okay, well, unfortunately, actually here, what if we do, is the reflection less?
I think that might help a little bit.
Mm.
Thumbs up. Oh yeah, that's looking much better. We still see reflection, but we can see the area.
Okay, done.
Good.
Yeah, Moshe still has to see.
Oh,
That would be good. Okay, so the first thing I'm going to do is set our overall mission altitude and flight speed. So right now we'll do it at 100 feet AGL. Flight speed we'll set that to 12 knots. All right, and now I'm going to select a survey mission. So we'll set our takeoff point to be just in front of our aircraft. Now I'm going to set my polygon. So that's just the area over which I want to capture photos and take data. Let me adjust all the mission parameters later.
Yep, zoom out a touch on the map. Okay, I see where we're at now. Okay.
Okay, so now that I've made our polygon, I'm going to start setting all of the mission parameters. So we want to continue the mission at 100 feet. Trigger distance, so our distance in between photos along the axis of the aircraft is currently set to 8 feet. Our spacing is set to 24 feet. And just for the sake of expediency, I'm going to up that to 50 feet.
Which make the trigger distance 20.
Sure.
And a side note on this, determining the appropriate trigger distance and spacing is a function of your photogrammetry requirements. And we've built a spreadsheet to help you determine if you need so much GSD, what altitude you should fly at, what should be your spacing, what should be your trigger distance. But for the sake of this demo, we're just typing in approximate representative numbers, but you can use the spreadsheet to calculate exactly what these numbers should be.
All right, so now that we've finished setting our mission parameters, we can also set turnaround distance at 50 feet. So that's the distance between the edge of the desired data capture area and the back of where the aircraft is going to be turning around. So we now have our return to launch. Yes, we do want to return to launch at the end of the mission. And now that all of that's set, I'm just going to double check all of the mission waypoints just to make sure that everything's okay. Flight speed 12. Takeoff 100 feet. All good. And here we can see some mission stats. I don't know if you can see it on your screens there. But we have the area that we're going to be surveying, the number of photos that we've programmed it to take, the photo interval, and the trigger distance here. And again, you get all of the photo count, photo interval, and trigger distance. That's all stuff that we calculated from the spreadsheet that Bill mentioned. So now that everything is set, I'm going to upload it. There's a little beep from the aircraft. I'm not sure if you could hear that, but in any case, we have a little done flashing up here. And yeah, we now have planned a mission.
Okay, any questions on mission planning before we take off and fly this mission?
oh my gosh, do you have an hour?
Okay, why don't we take 2 questions on mission planning then?
We have been flooded with questions into the chat, and
Okay.
And so they are talking about are you using Ardu or Pixhawk based? Are you the spreadsheet was awesome. Talking about a lot of it is it Pixhawk based? And then is there an option for flying the mission at a 90-degree angle? There were several questions that were up higher as well.
Yeah, here, just pause real quick. I'll give quick answers to the ones you've asked so far. So the aircraft avionics is the Pixhawk Cube Blue, which is made in the United States. We're running PX4 software on the Pixhawk Cube autopilot hardware. The Q ground control is the software that Moshe was implementing, Q ground control. Yes, it does have the ability to refly at 90 degrees. There was one other quick question, and I just forgot it.
We can come back to him, Desi. Let him do the mission.
Okay.
Okay.
All right, very good. So Moshe is gonna start up the aircraft and have it take off and fly now. And there's a lot of detailed specifications up on our website. Yeah. So it's climbing up to its takeoff waypoint. Any idea why it's not going? So something was uploaded incorrectly on this mission for some reason. Moshe's troubleshooting at this time.
You want to take some questions, Bill, while he's correcting that?
Sure, why don't we take a question? Here, I'll flip this around.
All right.
Desi, you want to go back to the questions that were in the chat?
Yes, I'm
Oh, there you go.
going through them now. Like I said, there were so many in there. What kind of program used for the inputs?
Q ground control is the ground control station software.
What made you decide to create a prop layout for the drone?
So we wanted in hover all 6 motors to be at equal thrust. And since the engine's on the rear end of the vehicle, the CG is aft of the center of the fuselage. So it's so we kind of needed more thrust in the rear than in the front. Additionally, the typical quadcopter has a the rear propellers on the typical quadcopter are less efficient than the front propellers on a quadcopter when it's moving forward in edgewise flight, because the front prop is taking the air that's coming in and throwing it down, and then the propeller behind it has to pull air from above and suck it down. So the rear prop consumes more electrical power per unit thrust than a front prop does. So one of the things we're doing is biasing towards better aerodynamics at high speed. So by spreading the motors out more laterally, the aircraft is able to be more efficient and have less drag in cruise. So that's one reason why we've spread out the motors on a much larger wingspan.
Awesome. Awesome. So where in Virginia are you for this mission?
We are flying over the city of Hampton landfill. So there's the big trash pile over there. And we've got a lease with the city of Hampton to operate here. And then we also have an airspace authorization with the FAA. So we're just inside the Langley Air Force Base, Class D airspace. And yeah, so we've got authorization to operate inside the Class D, and we do a lot of our flight testing here. Okay, this is the final mapping leg starting. And now it's going to turn around and return to launch. So I'm going to. Oh, okay. It's going to climb up. So as part of the RTL safety checks, it climbs to 100, as the way we have it configured, it'll climb to 150 feet and then head back to the launch site and land on its own. So now it's returning to launch. It's holding at the position for a little bit. There you go. Now it's coming down.
Bravo! Nice landing. Woohoo!
That was the autopilot landing it. On the last demo when Moshe was hand flying it, I was giving him a hard time for the hard landing. But yeah, the autopilot does nice smooth landings.
Awesome. Nice. Good job. So
And-
we do have a couple more questions that have popped up in here. First of all, how close to the landing point does it actually pinpoint the home point for landing?
So it's as accurate as the accuracy of the GPS. We have a standard GPS on the aircraft now, and that's accurate within about 10 feet. So it consistently lands within 10 feet of where it took off from. So realistically, in terms of a safe takeoff and landing area, you want to operate out of an area that's clear of obstructions, at least 50 feet in diameter. And you guys can go ahead, shut it down, and start packing it up. And actually, when you bring the drone back, pull out the SD card so we can show how easy it is to get the photos. Okay. Yeah, we don't have to just show them where the SD card is. Okay. Don't like plot the photos. Okay.
So the big question that we've been getting quite a few times through here is, what is the price point?
It varies with options. So if you just want the basic aircraft itself, no payloads, and an inexpensive Chinese ground control station, specifically a HereLink, that sells for $58,500, depending on the radio. So options that increase the price point, and we don't put a big margin on these other things. So the cameras and payloads, that adds a lot. So this Canon camera with lens, I believe the camera itself is $3,500. It's just a standard camera like for a professional photographer. And I think the lens on it is like $950 for the lens. And then at the other end of the spectrum, you could have the military quality EO/IR camera gimbals, and you can pay upwards of $40,000 just for that camera gimbal. And there's options for everything in between. Then radios. Radios is another big variance. If you want to push range and have Ethernet connectivity, Silvus makes a phenomenal product for radios. The high-end Silvus radios are $10,000 a radio, so you can, at an upper bound, spend 20 grand just on radio upgrades. And then, yeah, so depending on options, basically anywhere from $60,000 to $100,000, how you want it configured. Ground station is another big option. We were today using the desert rotor ground station that adds about 15,000 to the price point. And here, let me turn it around to show where the SD card is. Hold on quick. So here on the camera, Moshe's just gonna pop out the SD card. And there's our photos, geotagged, and we can plot those up another time. But so those photos are ready to go straight into Drone Deploy or whatever your photogrammetry software of choice is.
Oh, what types of material were used to build the drone to keep it so lightweight?
So it depends on the product. So the booms themselves, these are a pull-truded aerospace aluminum. The hinges here, these are 3D printed aluminum hinges. The fuselage itself, this is serial number 10. This is our oldest still airworthy aircraft. It's showing us some wear. There's some scuffs and stuff on it. The fuselage is pre-preg carbon fiber. And the motor mounts, these are 3D printed plastic. It's the Hewlett-Packard multi-jet fusion technology. These parts are not as much loaded. This is shapeways.com, versatile plastic. So depending on how the loads are on that component, we use different material technologies. That's whatever is the best value for that application. So every component has different materials it's made from.
Couple more questions. One of them is continuing on about the camera and the payload that you put on it, as far as what are the specs for the camera. And then on a different note, someone would like to know about the weather conditions that the drone could fly in.
Okay, this camera is from Canon. I forget the exact model number, but it's the 51 megapixel Canon camera. Like you can just buy on bnhphoto.com or wherever you want. It's the high-end professional DSLR camera from Canon, 51 megapixels. The lens on it, we selected a 24 millimeter lens that's rated for low optical distortion. It's a primary lens. There's no zoom on it. And it's better for photogrammetry to not have a zoom lens and a low distortion rating, especially out towards the edges. Oh. The camera is looking at me instead of the camera. Yeah, so this is just a prime lens on it, 24 millimeter. So that's the camera. Say again the next question, I'm sorry.
What are the weather conditions that the drone can fly in? Like
weather conditions. So let's first talk wind. So the maximum wind gusts we have tested in is wind gusts to 34 knots, which is like 38 or 39 miles per hour, which is much higher than what most multi-rotors are safe to fly in. In the pilot's operating handbook, we've specified a limitation of wind gusts no more than 25 knots. And we always want to test beyond the envelope. Then what our customers are able to do, so we know the edges of the envelope. So the pilot's operating handbook specifies wind gusts no greater than 25 knots. In terms of temperature ranges, we're designing for 120 degrees Fahrenheit down to 10 degrees Fahrenheit. In terms of precipitation, one of the cool value propositions of the aircraft, so it's all buttoned up right now, but all of the electronics are inside of modular line replaceable units, LRUs. And the LRUs are all IP65 rated. So all of the electrical connectors and the wire harnesses are, I don't want to use the term waterproof because that has very specific meaning, but all of the connectors in the aircraft are IP65 rated. So in the pilot's operating handbook, we have a limitation of 0.1 of an inch per hour rainfall rate that it's safe to fly in. Now, depending on the cameras and payloads you put on board, you may or may not be able to fly in that much rain, but at least the aircraft itself is able to fly in rain. So at 0.1 of an inch per hour, if you look at radar on your cell phone, there's the light green and then the dark green, and then it goes yellow. So the dark green is about 0.1 of an inch per hour. And we have tested the aircraft in the yellow region, which I think is up to like 0.25 of an inch per hour rainfall rates. So we've tested the aircraft in the, if you look at radar on your cell phone, in the yellow areas of rainfall rates. But for customers, you can only do 0.1 of an inch per hour of rainfall rate. So we talked winds, we talked temperature, we talked precipitation. Well, icing conditions, like we have flown it when it's snowing. But if solid precipitation were to accumulate on the blades, there's no de-icing on the rotor blades. So you cannot fly it in any icing conditions, much like any other small aircraft. There we go. So that's environmental limitations.
All right, so it looks like Jim had another question regarding the options for a camera angle for 3D mapping and modeling.
Yes, one of the things we're working on is an infrastructure inspection payload option. We're partnering up with Trillium. They're out in Oregon with the HD40 camera gimbal. And the HD40 XV is a high zoom EO only, daylight only camera that you can pan and tilt to whatever angle you want and program it. And that will is intended as an infrastructure inspection payload. We're still finishing that integration. I should actually back up to tell you our stage of the company. So Advanced Aircraft Company, we're an investor funded startup. We reached minimum viable product in Q4 of 2020, late last year. We just started shipping the aircraft. We've delivered 2 aircraft to date, so a brand new product. We have a couple simple payload integrations like this photogrammetry and mapping one on hand, and we're working on growing our payload integration options as time goes on. I do want to talk about how one other thing. So we've modularized the vehicle. So the nose cone is can be redesigned for whatever camera you want up here. And then there's also a belly payload bay here. So the top half is the fuel tank and the bottom half down here is an additional payload bay for payload. So for example, if you had a small lightweight LiDAR, like from Rock Robotic, for example, you can put that LiDAR in the belly payload bay. So depending on payload options, if it's not something that we've already integrated that's ready to go, we can help and integrate whatever payloads you want, or you guys could, if you have some in-house engineering capability, integrate whatever payloads you want. So it's an open and modular architecture, and just abide by the limitations in the payload integration section of the POH, and mainly like make sure the aircraft is within its weight and balance limitations, and you can integrate whatever fits within those limitations as you desire. Or if you want us to help you integrate your special payload, we'd be happy to help in that regard too. And we can work out some reasonable pricing for the integration costs of a different payload.
What are some of the autonomous options?
So right now, the aircraft, like the mapping mission you just saw, was completely hands off. Well, I think you had to re-upload the mission when it paused at that takeoff point. So I oftentimes, being an engineer, I like to be very precise with my vocabulary. So oftentimes when people say autonomy, they would classify what we just demoed today as autonomous because it flew hands off and flew its own waypoints. I would be more precise and call it fully automated. So if you were to program a waypoint that has it fly into a tree, it'll fly straight into the tree. So the aircraft is capable of fully automated flight operations where you program a mission, it takes off by itself, flies all those waypoints as you saw today, comes back and lands where you told it to land. So it's fully automated, but it doesn't have any situational awareness. That is on our product growth roadmap to include some situational things like obstacle collision avoidance and air traffic collision avoidance and things like that. But that's not available today yet.
So assuming if there's a situation, you can just break out of that mapping mission to.
Yes,
update it.
absolutely. Yep. At any point, you can just either pause the mapping mission, delete the mapping mission. You can just grab the joystick. And as soon as you grab the joystick, it senses that, oh, the pilot's giving inputs. I'm going to automatically change flight modes over to position control, which instead of a, let me flip around so you guys see me. So position control is a lot like DJI, where you're just commanding the translational velocity across the ground, and the drone flies itself to stay over that target location. But yes, at any point, if it's doing a mission, if it's doing something you didn't expect it to do, you can just take over manual controls and give it new instructions and manually fly it.
And what is the total amp delivery from the generator?
Okay, so it can put out about 2,000 watts of electricity, and the nominal bus voltage is about 48 volts. So math for Marines, I bad at math in my head. What's 2,000 divided by 48? Can someone?
2,000 divided by 48.
Yes, would be the amp, the maximum amp capability of the system.
Jim is doing the math.
All right, so like 42 amps. Yeah.
Yep.
Yeah, so 42 amps at 48 volts is 2,000 watts.
All right. And Ben, I believe you had a question farther up in the very beginning regarding the startup of the drone. And if he didn't get that answered, can you put that back in the post so I can recircle back to it? There, oh, there it is. I found it. Does the engine keep a consistent RPM once started, or does it change based on the load draw?
No, the engine does not keep a consistent RPM. One of the cool things about this technology is it's just like a modern hybrid car. So we are actively rectifying from AC power back to 48 volts DC. And the computer controls of the engine and propulsion system are monitoring how many amps are being drawn off the DC bus. And so if we're hovering at maximum takeoff weight, the engine's up at full power and it's turning at about 9,500 RPM. But if we're not at maximum takeoff weight and or we have some forward airspeed on the drone, the power required is less. And the propulsion system computer knows that it's more fuel efficient to run the engine at a slower RPM while still at full throttle to get a better fuel efficiency. So the engine is constantly changing its RPM to maximize fuel efficiency for whatever power is required at that moment. So another way to say it is we have decoupled the RPM of the engine from the voltage of the electrical bus.
And Kyle's asked, what is the percentage of flight is powered by the electricity?
100%. So the propellers are only turned via electric motors. The only thing that turns the propellers are electric motors.
Awesome. Man, we have had amazing questions. This has been fantastic. Sharing all this knowledge has been wonderful.
Hey, Kat.
Yeah, so here's one prop, and you can just see it's just an electric motor. There's no drive shafts in here. And the engine itself, the crankshaft of the engine only spins this starter generator. So there's no drive shaft. So it's makes it a lot simpler from a maintenance complexity perspective. So all these components are modularized LRUs. The most time-consuming LRU to swap is the engine generator unit. And we've demonstrated to our customers that they can do a complete engine change in less than 20 minutes. So, which is pretty rapid.
Wow. Well, we were even noting that the whole setup of the whole system, how fast that went.
Yeah, it's as fast as a small battery-powered multi-rotor. Yeah, so let me back up. So Advanced Aircraft Company, we are in the business of selling greater productivity. We sell greater productivity in a number of ways. The first is long flight time. So we can fly 2 hours at a time with a 4-pound payload. So say you were to do mapping and you had to map large areas. This aircraft in a single flight can map anywhere from 800 to 1,400 acres per flight. The typical battery-powered multi-rotor maps anywhere from 100 to 200 acres per flight. So that bound is a function of how aggressive or how conservative you want your mapping assumptions, like what's your percent overlap to the front, what's your percent overlap to the side, how fast you can set your shutter speed. So the faster you set your shutter speed, the faster you can fly without motion blur. So with very optimistic assumptions, this aircraft can map 1,400 acres per flight at less than 1 inch per pixel GSD, ground sample distance. And with very conservative assumptions, you can map 800 acres per flight. So that's better performance than an EB. And we're carrying a much larger camera than an EB2, which is dramatically better performance than a battery-powered multi-rotor. So yeah, selling greater productivity, map very large acres very quickly. Quick setup, quick pack up time. As you guys saw the live demo of the setup of the vehicle. We've demonstrated 4 minutes from the time I put my car in park to the time the drone is lifted up off the ground. That's with 2 trained operators, but with 1 week of training, assuming you're already a proficient battery-powered multi-rotor pilot, I'm confident our customers can meet that mark as well. Another way we're selling greater productivity to level set expectations, let me use the paradigm of DJI. If something breaks on your DJI drone, you have to ship the whole aircraft back to a repair facility, and it's 2 or 3 months before you get your aircraft back to you. And that's what a horrible way to run a business is you own an asset and that asset is out of your hands for 2 to 3 months at a time. And we wanted to think about this differently. How do we sell greater productivity to our customers? How do we make maintenance, repair, and overhaul much more streamlined? So say you have a problem with one of the line replaceable units, all the complicated things are in a line replaceable unit. Call us up, tell us what the problem is, and we'll say that's a problem within this LRU. We will FedEx overnight a replacement LRU to you. The box shows up in the morning. The longest LRU to swap out is the engine generator unit, which can be done in less than 20 minutes. All the other LRUs are even quicker than that to swap out. And then your aircraft is back up in the air, generating revenue for you again before lunchtime, the very next day. And contrast that with 2 to 3 months with DJI. So that's the third way in which we're selling greater productivity, is a much more streamlined maintenance, repair, and overhaul process. And it's not like that's a brilliant new idea for me. That's the paradigm of manned aviation. And so it's nowhere in a manned aircraft, if something breaks on your manned aircraft, does the whole aircraft have to go back to the manufacturer. You just replace the line replaceable units that need to be replaced, and then that aircraft flies to its next destination with paying passengers again. We've architected our drone like a manned aircraft in that way, that if something breaks on it, we just swap out that LRU. You send us back the damaged LRU, we'll deal with it later, and you have your aircraft back out on the job site before lunch the next day, generating revenue again.
Awesome. Well, it looks like we're almost out of time, so I'm only going to take this one last question.
Okay.
Jennifer Pigeon was wondering has the team worked on RDK options?
That is on our product development roadmap. So right now, this is HAMR Block 1, our minimum viable product that's selling now. One of our upgrades in HAMR Block 2 will be RDK GPS. And it's actually also going to be a dual RDK GPS. So you can remove the magnetometer, and we'll have 2 RDK GPSs. So with the 2 position sources, you can resolve your heading angle and remove the magnetometer. And this way you can fly close to electrical utility lines without interfering with the magnetometer, because there is no magnetometer at that point.
Awesome. So I would like to just kind of wrap it up with some parting words, some great thoughts from your side, share some of your experiences and a little bit more about the company and what you hope.
Yeah, wonderful. So moving forward, we're looking to grow our sales. Obviously, as an investor-funded startup, growing the business is incredibly important to us. And so we're looking for operators who have their pilots working 40 hours a week every week. As you look for productivity is a key metric of interest for those use cases. So if you're working 40 hours a week every single week, your business model is driven by the labor cost of your pilots, and you're less sensitive to the price point of the drone. And it's interesting. Let me use the analogy of a ditch digging business. Say you owned a business that dug ditches. The cheapest way to get into business is you go buy a pick and a shovel and you can start digging ditches the very next day. Or you could go buy a ditch witch, and a ditch witch costs about 100 times more expensive to purchase than a pick and a shovel. And you ask yourself, well, what's cheaper? And the answer is it depends on how much ditch you have to dig. So if you have to dig a lot of ditches, it sure is a heck of a lot cheaper to own a ditch witch and dig ditches, have one person, make that one person very productive. You can dig a lot of linear feet of ditch per day. But conversely, like if you don't have a lot of ditch to dig, it's cheaper just to buy a pick and a shovel. So moving forward, we're looking for drone operators that have a lot of work to do, and their pilots are working 40 hours a week, every single week. And those are our customers. So anyone on this call, or if anyone on this call can make introductions to drone operators who have that pain point, that would be wonderful. And that's where we're looking at moving forward.
Awesome. Awesome. And I know you do have that position available.
Yes, we are currently looking to hire a mechanical engineer. We would like someone ideally with at least a few years of work experience in the drone industry. So we're looking for a mechanical engineer with drone experience. And if anyone on this call or anyone on this call knows of somebody as a mechanical engineer with drone experience, please have them send us our resume. We've also put a posting up on Women in Drones for that position. And that's another way to find out more information about the job posting as well.
Awesome. Awesome. And it is the company, where is the company based at? And is that where the work would be, or is it going to be spread throughout the United States? How does that work?
The company is based in Hampton, Virginia. And yes, we're all in Hampton, Virginia. And this job would be located in Hampton, Virginia. So Southeast Virginia, it's about a 3-hour drive to Washington, D.C. We're very close to Norfolk. And it's a really neat area. A lot of military in this area. Actually, every single military service has a base close to here. It's a bit of a urban sprawl area, but if you want a little bit more elbow room, you can move to Williamsburg, Virginia. Lots of history and colonial, and I live in Williamsburg, Virginia. So it's a really neat area to work to. Lots of young folks in this area as well.
Well, I put your information into the chat. I hope that was okay to share with everyone, because
yes, please.
We had a lot of people responding into our chat, and Chris actually had asked specifically about where you were located, because he has a school in the area as well, and so he was hoping to connect as well. So I put that information in there. And
wonderful, thank you.
We cannot thank you enough. What a fantastic presentation. It was awesome. And your knowledge is just amazing.
Well, I stayed in a Holiday Inn Express last night.
Yeah. Well, we are so thankful, and thank you for just this time of doing it, sharing your knowledge, sharing your drone, and being a part of Women in Drones. It's just, we're very grateful for that.
And we're very grateful to participate with your organization. So thank you very much, and thank you for the opportunity to present today.
Well, thank you for doing so. And thank your team too, because they did a
Yes,
fantastic
yeah, they're
job.
actually busy working on another task right now, but I'll have them say goodbye.
Okay, all right.
There we go. You guys want to wave goodbye quick? That's Moshe and
All
Paolo.
right.
Wonderful.
All
Awesome.
right.
Well, thank you very
Well,
much,
thank you.
everyone.
Okay,
And
thank you. That kind of wraps it up.